When we defined organic chemistry, we defined it as the chemistry of carbon-containing compounds. We also know that it often has hydrogen, what I call carbon's best friend. But other than carbon-to-carbon bonds and carbon-to-hydrogen bonds, organic molecules can have other structural features. There is only a limited number of common structural features that we find, and we call these functional groups. So if you look here, a functional group is an atom or a group of atoms with characteristic chemical and physical properties. So we often have a backbone, a carbon backbone, which is what we denote as R when we're looking at it, when we're trying to make a generalization. So we have this carbon backbone, and it is going to be bonded to a functional group. Now remember, these functional groups have things that are in common, and the type of things that functional groups will contain are heteroatoms, which we know are anything that are not carbons and hydrogens. So commonly nitrogen, oxygen, sulfur, and the halogens. The functional group may involve a multiple bond, or it could have both of those things, a heteroatom and a multiple bond. What we find is that we can classify organic compounds by their functional groups, and these functional groups will determine a lot about the organic compounds, such as their shape, their chemical and physical properties, which would include, chemical properties include the types of reactions they'll undergo, and organic chemists even use the functional groups to name compounds. For example, if you've studied biology or anatomy and physiology, we know about amino acids. Amino is a functional group we call an amine, and the acid part of that comes from the functional group called the carboxylic acid. So right there, there's two functional groups within that particular compound. So our goal is not to know all we can about a variety of functional groups, but our goal is, given a molecule, be able to identify the functional group within that molecule. Functional groups, not only do they classify these compounds, but they're also oftentimes the site of a reaction. So there's three common types of functional groups, and you will see three tables that have these common types of functional groups. These tables are given to you. You are not required to memorize it. The first type is a hydrocarbon. Now, hydrocarbons, by their very definition, these are only going to contain carbons and hydrogens. The second group is when we have single bonds to a heteroatom. And remember, heteroatoms are things like nitrogen, oxygen, the halogens, or sulfur. And then the third type is compounds that contain a carbon to oxygen double bond, or what we also call, this is a carboxyl group. The goal of all of this for us is to identify the functional groups. So that's our goal. So here's a table, and we're just gonna briefly look at three, and we'll come back. This table is one that contains carbon and a heteroatom. So you'll notice here that it has carbons and then a single bond to any of the heteroatoms, which are going to be like nitrogen, oxygen, the halogens. Now here is it has a general structure. So this is kind of what we're looking for. Remember where R, you see here, is a carbon backbone, and it may be a little different for each, well, it will be for each different molecule. Now this column right here is just an example, and it's usually a very simple example of what it might look like. Now the type of compound, which is usually what your book is asking you to identify, is here. And this is what, if we call the functional group in a very general term, is here. Most often, this is what your textbook is asking for. So here's one. This is with the heteroatom. Here is where we have carbon with a double bonded O group. And so you'll notice all of them have the double bonded O. Here's the general structure again right there, where R is a carbon backbone, and it could be different for each compound. And then the examples, this is just a simple example of what that would look like. And here we have the type of compound that we are looking for. And lastly, here I have the hydrocarbons, and so this just contains carbon and hydrogen. If you notice in here, what we're really looking for is the type of bonds. So we have double bonds, which have, these are the names, triple bonds, and then one of the easiest ones to identify are these rings with double bonds between every other carbon. So here's what we're going to do, and this is, we're going to try to practice, and you have homework that will practice, but this gives you an idea. It might be helpful to have your book open and have these tables available. So here I've circled functional groups. So I see here, remember there's 3 types. We have a hydrocarbon, that's one table. We have a carbon to a heteroatom, single bond, which really is just R, they call R, or a C double bond O. So those are the 3 tables that we have. So this first example, which I'll just call A, I only have carbons and hydrogens, and I circled here double bonds. So coming here, and let me erase the table so it would be how you were looking at it. So here I only have carbons and hydrogens, and there it tells me I'm looking at the table with hydrocarbons, and I see here that there is a double bond, and the double bond comes from the type of compound we call an alkene. So both of these, this is an alkene, and this shows an alkene. Now let's look at letter B. So in letter B, I noticed to myself, well, here's a C double bond O, and that's one of the tables. Now, on the C double bond O table, it's important, they're all going to have a C double bond O, so you have to look what's on either side of it. So on this side, I have what we would call an R, that's just carbons. And then I have a C double bond O, and then I come down here and there's an O, and then there's more carbons and hydrogens, which is an R. So in my mind, I'm looking for a C double bond O that has R on one side and OR on the other. So find the table for C double bond O. Here it is. Let me erase this writing. And so all of these have C double bond O. And so you're looking what's on either side. So look, here in the middle is a C double bond O. I have R and H. Okay, that's not it. Here's a C double bond O. I have R and R. Not it. Here I think I'm getting closer. I see a C double bond O. I have an R and then an O and an H. But mine had an O. This was not an H. It was an R. And look, I have an R, the C double bond O, O, and then another R. I'll erase it so you can see. Right here. So this is called an ester. So this group that I have circled here which is R, C double bond O, O, R is an ester. Okay, here I notice I have several things going on. These two look the same to me, even though they're mirror images. So I have a C double bond O here in the middle. And on this side I have an OH, and on this side I have what would be called an R. And this is the same C double bond O. I have OH on one side and an R on the other. So I'm going to go back to my C double bond O table. And let me erase. So they all have C double bond O, and I want R on one side and OH. So I look right here, I see where I have an R on one side and OH on the other. So this is called a carboxylic acid. So these two right there are carboxylic acids. Now the second one, these two are obviously both the same. They're attached to some carbon group here, which they just call R's. But they are a single bond to a heteroatom, so it's going to be on a different table. So this is hydrocarbons, that would not have a heteroatom. This is C double bond O, it wouldn't be there. Here we go, a carbon heteroatom single bond. So I'm looking for OH, and there we have it, an R with an OH. So this is an alcohol. So these two here are alcohols. So let's try one more. And you can try to do this before I do it, but I'm going to go ahead and try. So looking at the first one, I'll look at this one. I see that it's just carbons and hydrogens, and so I know there's a table that just has carbons and hydrogens, the hydrocarbons. I find these the easiest. These are called aromatic compounds. Now, if you are using a homework problem and you don't see aromatic, but you see benzene, notice that they're the same. So aromatic. So this is how I think. There's aromatic. Here's aromatic. And here's aromatic. All of those three, each one of these had something that was aromatic in it, the rings. Now the second thing I'm going to look at is this OH. So I know it has a heteroatom, but it's a single bond. And so I know this is hydrocarbons, it's not there. This is C double bond O, it's not there. So here we have a carbon heteroatom single bond, and I'm looking for OH. And so here it is. Remember R is just carbons and hydrogens, but there's my OH. And so this is an alcohol. Now again, because I feel like on one of the homework problems, you're going to identify it as an alcohol, and then it's not going to have alcohol there, but it does have hydroxyl group. So then check hydroxyl group. So my OH, this is an alcohol. Do we have any other alcohols on the things? Well, I do see an alcohol right here. And I do see another one, even though I didn't circle it, right there. I'll just circle it now. Okay. And so now let's look at this one. Okay, so here's a guy that has an N. So it doesn't have, it has a heteroatom that's single bonded. So that tells me what table, and it has an N. So I'm looking for the single bond heteroatoms. And as I go through, this has halogens, this has OH, this has O in the middle. Oh, there's an N. And you can see a single bond with an N could come with a variety of H's. And so that's called an amine. Now, are there any other N's? And on this one, I look here, here is an N, but look very carefully. This one is next to a C double bond O. That puts it, the C double bond O, since they're right next to each other attached, it puts it on a different table. Let's check out the C double bond O table. So look right here. These two are not separate functional groups or separate compounds, but you have a C double bond O and then R on one side, which are just carbons, and then an N on the other side. So if you have them right next to each other, that's called an amide. So do you see the difference between an amine, which we had up here, and the amide? And the difference is the amine is next to, would be considered an R, and then this is an R, and it has single bonds, where the amide has a single bond to the C double bond O group. So I think I have two more to name down here on the third one. So this guy, I see a C double bond O, so I know what table to look at it. On this side I have R, and on this side I have H. So I need an R and an H. Okay, let me erase, I want to erase this. So these all have C double bond O's as you look through the whole thing, and I need an R and an H. Look here at the first one. There's an R on one side, and it wouldn't matter which side they're on, and an H. So that's called an aldehyde. Now this last one is not written, it's written in a condensed structure. So let me think, this would be like C, it would have 3 hydrogens. Then it would have an O, and then it would be attached here. I'm going to write it out here. So it would be like CH3. Then it has an O, and then it's attached to that aromatic ring over here. It goes, which there's not. So I'm looking, it's a single bond, and it has a heteroatom, right? Because it has an oxygen, and it's single bond, not C double bond O. So, and I have on one side, this would be considered an R, carbons, and this would be considered an R. So it's an oxygen between 2 carbon groups. I need the single bond one. Okay, let me erase this so we can really look at it. Okay, so I have an I have an oxygen that's in between. So here, this is halogens, it's not this. It has an R on one side, but it has an H, not. Okay, here we go. Has an R, which just means carbons on one side, and R, which means carbons on the other side. Now, and here it has the lone pair, but remember when you draw condensed structures, you take out the lone pair. So you might not always see all the lone pairs, but they're there. So this is an ether. So this guy right here is an ether. But notice I felt like I had to draw it out from the condensed structure. And you might not have to. That wouldn't be a requirement. Identifying functional groups does take a little bit of practice, and the more you practice, the more you get familiar with the tables, and the list of them and how many of them almost seems to shrink because you get more familiar.